students, welcome back. So students, how are you? Fine? Okay. So we have been discussing the chapter circular motion. Now let us start with the next module of this chapter circular motion. In this module, oh yes, we are going to discuss the concept of angular acceleration. Now students, again, 11th standard, you have studied the concept of linear acceleration. That was in which motion? Yes, translatory motion. Here in circular motion, we have angular acceleration. So, are you ready? Can I start up with the module? Okay. First students, what we are going to do? Yes, very good. We are going to define angular acceleration, but hold on. Angular acceleration, there are two types. One is, very good, average angular acceleration. Second one is, yes, instantaneous angular acceleration. First, we are going to define what is average angular acceleration. Okay, for that I am going to consider a very small particle. This particle is performing a circular motion, alright, and point O is the center of the circular path traced by the particle. This particle, alright, is at position A. Alright, now you can draw a radius vector, so OA will be my radius vector. Is that clear till now? Fine. Now students, let us assume that this particle is moving from position A to another position B in time t1. What is it? It is moving from position A to position B in time t1. Now see there. What will be the radius vector? OB will become the radius vector. Alright. Now, the radius vector has swept through an angle. Alright. So theta 1 is the angle swept by the radius vector, and the particle will have some angular velocity. Omega 1 is the angular velocity of the particle. Is that clear? Fine. Now students, let us assume that this particle is moving from position B to another position C. Alright, it is moving from position B to another position C. Hold on. Let us assume that this particle moves from A to C in time t2. Alright, in time t2, where it has moved from A to C. In the animation we saw it was moving from B to C. But t2 is the time taken by the particle to move from A to C. With respect to A, it has reached C in time t2. Is that clear? Fine. t1 was A to B. t2 is A to C. Is that clear to you? Fine. Now, let me draw radius vector. OC will be my radius vector. Now again, see there. With respect to A, alright, with respect to A, the radius vector has swept an angle theta 2. With respect to A, the radius vector has swept an angle theta 2, and omega 2 is the angular velocity of the particle. Is that clear? Right now the angular velocity of the particle is omega 2. Now students, angular velocity has changed, so we can define what is angular acceleration. Angular acceleration or average angular acceleration is defined as the time rate of change of angular velocity. Alright, average angular acceleration. What is the formula? Oh yes, alpha average is nothing but omega 2 minus omega 1 upon t2 minus t1. Omega 2 is your final angular velocity, omega 1 is your initial angular velocity, t2 is final time, t1 is initial time. Is this clear to you? Fine. Now students, the second type of angular acceleration is instantaneous angular acceleration. Again, I need not go into all those animations. Directly I can define, because already we have seen what is instantaneous angular velocity. Yes or no? Okay. Then I can ask you, what is instantaneous angular acceleration? Yes? Yes? That's good. What you're saying is right. So instantaneous angular acceleration is nothing but it is the time rate of change of a limiting angular velocity. Limiting angular velocity means it's a very small interval of time and delta t tends to 0. Is that clear? So what is the formula for instantaneous angular acceleration? Alpha instantaneous is nothing but limit delta t tends to 0, delta omega upon delta t, which is nothing but d omega by dt. This is your instantaneous angular acceleration. This we take when the time interval is very, very small. Is that clear to you? Fine. Now students, we can go on to SI unit. What is the SI unit of angular acceleration? Yes, it is radian per second square. And what are the dimensions? No, not that. Dimensions are m raised to 0, l raised to 0 and t raised to minus 2. Exactly, radian per second square. Alright, now, angular acceleration is a vector quantity. How to find the direction? Right hand thumb rule? No, hold on. Wait. How to find the direction? I'll explain it to you. How to find the direction of angular acceleration? For this, I'm considering a particle. this particle is performing a circular motion. Now, in what direction it is performing? Yes, it is performing in the anti-clockwise direction. Then according to right-hand thumb rule, we can say omega is pointing up. Observe it. What's going on there? The particle, you see what's happening to it. The omega of the particle, the angular velocity of the particle is increasing. Yes or no? It is increasing. Angular velocity is increasing. Now students, if angular velocity of the particle is increasing, then alpha is in the direction of omega and it is taken as positive. Okay? If the angular velocity of the particle is increasing, then alpha and omega both are in the same direction and alpha is taken as positive. Is that clear? Now, let us take a second case. Here again the same particle is going to perform a circular motion. And what is the direction? Yes, it is also performing in the anti-clockwise direction. So we can say omega has to point up using your right hand thumb rule. Now see what is happening. It is slowing down. Slowing down means the angular velocity of the particle is decreasing. So if the angular velocity of the particle is decreasing, then alpha is in the direction opposite to omega and it is taken as negative. Is that clear? This is how you find the direction of alpha. Omega increasing, alpha in the direction of omega and positive. Omega decreasing, alpha is in the direction opposite to omega and it is negative. Is that clear? So students, in this module, we have learned what is angular acceleration, the two types, average angular acceleration and instantaneous angular acceleration, and we have seen how to find out the direction of angular acceleration. Is that clear? I'll catch you up in the next module, students. Until then, keep working, students. You can do it. You're all born to win.